Welcome to aminacademy.com. In physics regarding oscillation, let us do some solving problem. Look at this example. Which of the following examples represent a periodic motion? A swimmer completing one return trip from one bank of a river to the other and backward. This is not a periodic motion. Not. Since the motion of a swimmer is to and fro but will not have a definite period because the exact time is not given as well as it is not a definite, it have no definite period, so it is not a periodic motion. A freely suspended bar magnet displaced from north to south direction and released. Here, since freely suspended magnet, if once displaced from north to south direction and released, it oscillates about this position. It is a periodic motion. Since north to south and south to north, it when it is released, that means suspended bar magnet displaces periodic motion. Hydrogen molecules rotating about its center of mass. The rotating motion of a hydrogen molecules about its center of mass is periodic. Since the molecules rotating about center of mass periodically. An arrow released from a bow. The motion of an arrow released from a bow is non-periodic. It's not a periodic. Not a periodic because it won't return and time control is not exact. So that arrow released from bow, it goes, it won't come back. So it's not a periodic. Next question. Which of the following examples represent nearly simple harmonic motion and which represent periodic but not simple harmonic motion? Here, the rotation of Earth about its axis. Since the rotation of Earth is not to and fro motion about a fixed point, thus it is a periodic but not as such. It is a periodic but not simple harmonic motion. Since rotation of Earth goes in one direction, it won't come back. It won't rotate opposite direction. So it is a periodic. Every time it follows a periodic motion, but it's not as such. Motion of an oscillating mercury column in YouTube. It is as such. Simple harmonic motion. It follows a regular fashion in to and fro motion or up and down motion. Motion of a ball bearing inside a smooth curved ball when released from a point slightly above the lowermost point. It's also as such. It follows. It is simple harmonic motion. General vibration of a polyatomic molecule about its equilibrium position. General vibration of a polyatomic molecule about its equilibrium position is periodic but not as such. In fact, it is a result of superposition of SHM executed by individual vibration of atom of the molecule. So, it is periodic but not SHM. It is periodic but not simple harmonic motion. Now, next question. Figure depicts 4xt plots. That means distance and time plots for linear motion of a particle, which of like plots represent periodic motion. What is the period of motion in case of periodic motion? Yeah, question A is not periodic. The question is asked, what is the periodic motion? It's not it's not periodic because it's not run from motion, not period. Yeah, B is a periodic. B is a periodic. It's a periodic motion, and they ask when if it is a periodic, what is the period of motion? Here, look at this. The period of motion is from here 2 seconds here, and periodic motion and period 2 seconds. That means from this point to this point is 2 seconds, or from here to complete rotation is a 2 seconds here. Now here is not periodic. Not periodic because it's not regularly moving. This is 1 to 4, 4 to 7. So the difference is not constant. Here D is periodic. It's a periodic motion and having period is 2 seconds. Next question. A particle is in linear simple harmonic motion between 2 points A and B, 10 centimeter apart. Take the direction from A to B as the positive direction and give the sign of velocity, acceleration and force on the particle when it is at the point at the end A. Here, look at here, these are the periodic motions given from in the figure. The point A and B 10 centimeter apart. A to B is 10 centimeter apart given are the extreme points of the particle in simple harmonic motion, and the point O is the mean position, center point of A and B. The direction of A to B is positive. So A to B is this direction is positive and opposite direction is negative. Now the first thing is at the point A is what? At the point A, at a end point A, the extreme position of SHM, the point A is extreme position of SHM. In that extreme position, velocity is 0, whereas the acceleration is and force are directed towards the point O or negative. That means at the point A, from the mean position, it's the left side, so its velocity is 0, and because it's a stopping point, and whereas the acceleration and force are directed towards the point O are negative. Direction of the acceleration is negative. At point A, the extreme position velocity is 0, acceleration and force are directed towards O and are positive. Now first one is at end point A, the extreme position velocity is 0, acceleration and force are directed towards the center and are positive. The second one is at point B. At point B is right side and the second extreme position. This is a midpoint O and this is the first extreme position and second extreme position is B. Whereas the velocity is 0, whereas the acceleration and force are towards the point O and are negative. Third one, at the midpoint of AB going towards A. Suppose from the point going towards A is at the midpoint O, while going towards A, velocity is negative because from the midpoint to extreme point, velocity is negative side and velocity is maximum. The acceleration and force both are 0 at midpoint. Then question number D, at 2 cm from B towards A. 2 cm from B towards A. From B towards A it comes. So at 2 cm away from B, that is at C and going towards A, B is negative. Acceleration and force being towards point O are also negative. Then at 3 cm away from A going towards B. At 3 cm from A, that is at D, that is D away from A as well towards B, B is positive. Velocity is positive, acceleration and force being directed towards O also positive. Then here next is at 4 cm away from B going towards A. Away from B going towards A. At 3 cm at a distance of 4 cm away from A and going towards A, velocity is directed along BA, therefore it is positive. Since acceleration and force are directed towards OB, both of them are positive. This question is regarding about the direction and maximum or minimum about SHM. Next question. Which of the following relationship between the acceleration A and the displacement x of a particle involves simple harmonic motion? Here, look at here, A equal to 0.7x, B equal to, that is A equal to minus 200 x square, C equal to minus A 10x, D equal to 100x cube. Here, only C is represent SHM. Here, this is SHM. The relation is acceleration is minus 10 times the displacement. And other things, only C, that is A equal to 10x represent SHM. This is because of the acceleration is proportional to its opposite to the displacement. Acceleration is opposite to displacement. But here, this is A is 0.7x, it's not a SHM because it's both are positive. Here, A equal to minus 200 x square, but it is x square, it's not relation is square, only x must be there, so it's not SHM. It's not SHM, it's not SHM. Only C is a simple harmonic motion. So far we have done about SHM, some questions regarding the direction, and maximum minimum about velocity and acceleration and its direction. We have done. Please subscribe our YouTube channel.